I like the end. So that, I had to assume, I'm not 100% sure, but was probably made with a dry erase board that is magnetic. He might, no, he doesn't explain why. But if you notice, like, the augmented gravity when things were launching, if you put a board at an angle, it won't have as much gravity as if it was, like, something launching straight up. So, like, when the ping pong balls got launched, it, like, slowly kind of dropped down. It's because the angle of the board. But then the cool thing about making something like that, to hopefully inspire you for Discovery Days or something like that, is that they could have done that frame by frame. So you could record one section and then move all your magnets and everything, record the next section, move all your magnets and everything, because it kept coming in from outside the frame and then rolling off the other side of the frame. So it wasn't probably actually continuous. So I like to show you guys cool things like that, just because, one, it's interesting, and two, it might inspire some Discovery Day stuff. Today we're going to be talking about two different things: compound and subtracting probability. So if you want to make your life easy, head your notes with the word probability, and then like a semicolon or colon, I forget which is which, and then put subtracting or compound / subtracting. So I'll write up here what you need. 1.2.7 and 8. Probability. It's two different lessons that we're going to cover today. Subtracting and compound. I think I was in here, somebody was like asking me how I make that bracket thing, and just because we listen to music, one thing that took me forever to be able to make was the treble plus symbol. Making those is really tough too.
That's why I'm on the bass.
That's why I put. Well, and well, I was gonna say in percussion, but in drums, we don't really care what clef we're in. Yeah, it doesn't really matter. So I'm gonna read just because we got to go a little quickly today. I'll move this down on this screen so you guys can see it. So far in this section, we've worked with probabilities involving one specific desired outcome. So now we're going to invest the probabilities of compound events. Remember, if it's blue, you can click on it. Compound events, a compound event is probability of an outcome that depends on two or more other events. For example, finding the probability that both a red ball and a blue block are drawn from a bag in two different draws. So, compound events are events with a combination of outcomes. In today's lesson, we're going to talk about the probabilities of either and or situations. And there's also and situations that we'll get into talking about. So there's events where we might say, well, I'll be happy if this or that happens, or I'll only be happy if this and that happens. Those are two different things, right? Because it's going, actually, this is a good question to ask you guys. Do you think it will be easier or harder to get two different things to happen as opposed to just one? Why?
Because you have to get, there's like one thing of probability to get, and then there's another one. So you have to have twice as hard to get both things from different events.
So let's just see where we're at right now. Forget the textbook for a moment. I have a coin and my mega die. I want to know what's the probability that when I flip this coin and roll this die, I will get a heads and, I don't know, a 4. Talk with the group for a moment. What do you think would be not and? I want both to happen. A heads and a 4. I'm only doing each thing once. Talk to each other for a moment. All right, now, we don't need to discuss whether you were right or wrong and how we get there, because we will do this later. But the actual probability of that situation, anyone really think you know? What do you guys think of it?
1 over 12.
1 and 12. There are actually 12 different outcomes there. All right, so moving on. Who are we talking about? Thomas helps around the house. Now, because Thomas's parents are a lot like me and they don't want to have to decide things, they've made a spinner. Right, so we have this probability spinner set up at the right. And we need to figure out what's the probability that he's going to do laundry. Now, what we know are the probabilities given to us up there. The size of the circle is accurate. So what it looks like, it is, as opposed to some math things we can't trust how it looks because the numbers are different. I need you, as a team, to figure out what's the probability of do laundry when we know do laundry and rake leaves are the same. They're the same size as each other. And there's a couple other things we can actually figure out are the same. So I bet we can do this in like 90 seconds to 2 minutes-ish. Go for it.
No. Clean bedroom is. Oh, clean bathroom. So that's 4.
Oh, you're gonna walk together now? That's not a third of a half. Well, never mind. I'm gonna be quiet. This is a third of the circle. If we talk in percentages, how much percent does the whole spinner have? 100%, right? What's clean bathroom? A fourth, right? It's a fourth of our spinner. We can trust the sizing. Now, there's 2 easy ways to do this, and one is really easy. How much probability do we have over here? A half. So if I just look at just the just the left side, what I really have is I want to do a half and then get rid of clean bedroom. Oh, snap. I can't take 3 away from 2. This isn't going to work. What do I need before I can add or subtract fractions? Mallory? By the way, I was like completely not serious when I said this isn't going to work because I was talking about something we don't do. We don't actually physically work with the numbers that are there because right now they're not common denominators. We can't do this. So easiest way to find common denominators, multiply by the other one. Now sometimes that'll give you the least common denominator and sometimes it won't. It doesn't matter though. All that we care is that they're the same. So we have 3/6 minus 2/6. What do I end up with? 1/6. But that's not my answer. Because 1/6 is this region. So in the region that we're looking for, as most of us have already said, half of a 6th is a 12th. So it'd be 1/12 is the chance of rake leaves, 1/12 is the chance of do laundry. Questions on subtracting probabilities? All right, we're going to go quick. Check out 20. Spinning either cleaning his bedroom or raking the leaves will make his aunt happy. I can pull this down. Sorry, I see you guys like straining to look up. So if we don't care which one of those happens, but his aunt's like, man, he really needs to clean his room, and the leaves could be raked. She'll be happy with either of those happening, not both, because you're spinning the spinner once, you can't get both. What's the probability of either of those happening? Talk with your team. What are we going to do with these fractions to get the either chance? If we don't care which happens, we add them. Because either is better. Right? Think about the spinner. I don't care whether I land in clean bedroom, right, this region over here, or if I land on rake leaves, which we could just go ahead and say is this section since I can see that one. So I'm going to put both those sections together. I can land in any of that. That makes it easier, which means we add them. So 1/12 and 1/3. Can I add these?
Yes.
You know, I just get like 2/15. No! Sorry, trying to make sure we look at the mistakes so we don't make them. Now, that's a pretty common mistake that people make. Because when we multiply fractions, it doesn't matter. Nothing has to match. Multiplying fractions is easier than adding or subtracting. This is when adding or subtracting is actually much harder. What do I need to do here? Do I need to change both denominators, Connor? Just change the 1/3. What do I need to make it?
4.
Yeah, by 4. So I multiply by 4 on top and bottom. My 1/12 doesn't change. But now I have 4/12, so we end up with 5/12. Preguntas, which means questions in Spanish. Anybody?
9.
That is no in German. Das gut? Ja? We're gonna skip that question. So we're gonna skip 22 also, but it's worth talking about because some people actually know the By Felicia reference, and then other people just, we can really easily understand why this doesn't work. Because if I have a third plus 2 more fifths, it doesn't become 3/8, right? That doesn't make any sense. I put these into here, but I need to make some common sizes of things. So I can cut this up into more pieces. I can cut this up into more pieces. And the easy way to do this, since I have 5 pieces in the one and 3 pieces in the other, what would be the common denominator? 15, right? Oh, I can't write on that. But if I took my 3 and sliced it 5 ways vertically, and took my 5 and sliced it 3 ways vertically, I'll make 15 squares in each of them, or 15 little sections, and then I can add them up. Oh, did I talk about the homework folder in this class yesterday?
Yes.
In Google Drive? Okay, so, sorry, my brain jumps around sometimes, especially when we're doing 2 lessons in a day. I essentially have no chance at staying focused. Let's talk about Steve real quick, and then I will talk about the, like Steve from, wasn't it Steve was in Blue's Clues?
Yeah.
But then they replaced him. Alright, Steve went to college and he got a job at the casino, right? So Steve shuffles up a deck of cards. 52. If you're not aware, there are 52 cards, actual cards, in a real deck, no jokers or wilds or whatever, 52 cards. The first 3 cards he turns over are an ace, a 4, and a jack. Okay? Explore, we're not going to use the E tool. How many cards are left in the deck? And this is where it gets hard. What is now the chance of drawing an ace? So these questions, guys, you take like 2, maybe 3 minutes to talk with each other. Write this out. Now remember, this was no replacement. He's got 3 cards on the table now. And he's still flipping cards over. He did not replace them. There are 13 different cards of 4 different suits. So 13 times 4 makes 52. I hate that I can't write on this. I don't know what happened. I need to try to relaunch my Smart Ink. I got something going on with my computer. Alright, real tough question. How many cards are left in the deck? 49. It's my Smart Ink still doesn't work. How many aces are left in the deck now? Anyway, 3, making our chance of getting an ace now. 3 over 49. So just think about how the situation's been modified, how things have changed. Every week, your parents get an update from Phoenix. And this week, in that update, it comes home to their email called like 7th grade update or something like that. They received a link that goes, actually I should keep this down here because we're recording, that goes to a folder called Hudson's Math Homework. In this one, and there was a little blurb from me saying like, hey, I'm trying something new. Check out this link if you need to help your kids with their homework. I need to catch up with CC3. There's nothing in there right now. So as we do more homework in CC3, I will try to do it and put it in there. But for CC2, if you go into here, and I haven't made folders for the other chapters yet because there's no reason to. Chapter 1, every homework that we have for Chapter 1, and I don't know, Mr. Smith's are labeled differently, so I'll have to try to label his the same. We're going to try to put 2 different versions in here, one done by me and one done by Mr. Smith. But if you're having issues on a homework, or if you want to see my answers from 111, there's my homework done out. 112, there's everything. 113, 114, every homework we do. Now I'm going to put little notes in here, like median means middle. I got to put it in order. I'm going to write more than what you would normally write probably, but that's to like really help you. So tonight, you're 117 or 127, 128. I hope I labeled those right when you guys came in. Did I? Yeah, 127. Those are done out right here. So if you're trying to check your work or check what you did. Now, I'm super like OCD when I do math. I'm going to show you this one as opposed to the other one. I always divide my paper in half. I fold it over to the binder rings, and I just crease it, and then I draw that line down. And then after every problem, I just draw a line across. And then my numbers are like boxed out or something like that. And I will make little notes here, such as like last night's homework. Well, this wasn't last night's. We're skipping this homework. Like, you're not going to do this one. But, you know, I make notes of like leave space for common denominators, stuff like that. So if you struggle, now I'm not sharing that link direct to you guys because I want you to have to be able to like go through your parents and talk to them about the problem. Because your parents should at least know that you're struggling. Even if they're not going to be your help resource, it's good for them to know like what's coming easy for you and what's more of a struggle so they can support you. So follow that link. Now I know like once you have the link, you could send it to yourself or whatever. But the link just gives you access to view these things. You can't edit or anything else. But yeah, use that if you need help on your homework. Now where are we? There we go. All right, we're switching to 128. Yep, sorry. This is welcome to compressed 7-8. We're going to go fast. I'm also hoping to give you guys time for homework, but I got like 20 minutes left. I like Eustace here because I always think his name looks like Estes. Like Mr. Estes. Yeah, Eustace is in problem 130. So, when we talk about probabilities, there's a lot of work that can be done with them. We just talked in the last lesson, over back on the lesson we did about adding probabilities when it's the either situation, like this or that. So if we have like 1/2 and 2/4, is it 3/6?
No.
No. And 3/6 is 1/2. We should pretty quickly recognize that. What did Eustace do that we shouldn't? Yeah. Yeah. He just went straight across without finding a common denominator. Now, here's what's frustrating. Still can't write. If we were multiplying, we'd go straight across, and this would turn into 1 times 2 is 2, and then 2 times 4 is 8, maybe 2/8, or we could reduce that to 1/4. If we were multiplying, it'd be a whole lot easier. So we're moving on beyond that problem. So Fruity Tooty Chews, they just can't use the regular things, you know, like the little, they're like, so they, at the place in Coshocton I used to go to, they were called penny candy. But they were like made by Tootsie Roll or whatever, the little fruit things. So imagine that, right? Little fruit candies in a bag. So Lindsay tells you, I got the bag full of candies, paper bag, so you can't see into it. If you reach into the bag, you have a 1/3 chance of pulling out killer kiwi. Sounds dangerous. And a 3/5 chance you will get crazy coconut. So, what is the probability that you will get coconut or kiwi? Solve that at your table group right now, please. Coconut or kiwi? It's 131. Sorry, I'm moving screen so I can write. What do I do with these probabilities since it is or?
You add them.
We add them. Do we have a common denominator? No. What's it going to be? 15. That's a nice common denominator with 3 and 5. So multiply by 5s over here. Multiply by 3s over here. And we get. So now your buddy comes up.
Hey, buddy.
And he says, I really don't like coconut or kiwi. What's the chance I get not coconut or kiwi? So, talk to your group real quick. Make sure you all agree on this.
It must be. Must be. What?
And I should use some cards probably. Simon, what's the chance that we don't get coconut or kiwi? 1 out of 15, because we know probability when we look at everything is 1. Right? We got to total up to 1. So now a weirder question. Lindsay's like, I bought this candy last week. I can't quite remember how much I have in here, but I know these probabilities are true. And she says, I'll give you all my candy if you can guess how many pieces are in the bag. So, what are some options for total pieces in the bag that we could have? Talk with your group for a moment. Remember, there's a bag of candy on the line right now. Brayden. Yes. What does your group think?
We think that, kind of how we talked about this yesterday with a different problem, that every time, it's the same probability probability, then they would just be doubling it. Like, so it could be like 30 pieces of candy and 2 of them aren't those flavors.
Ah, so if we had 30, then there'd be 2 that aren't the kiwi coconut. Okay, so you're saying 45, 60. So we could keep going, right? If we keep like 15 more candies, could there be 15? Yeah, right. So we have that option first. So there might be 15 or 30 or 45 or 60. What do we call these when we like take the start number and 15, 30, 45, 60? Ooh, close. You're doing the common mistake. People switch these words around. Multiples. So be careful. Factors and multiples. Honest truth, I mixed up for like ever until I decided, okay, I have to get this straight because I'm a teacher and I can't keep screwing these up. Factors are when you break things apart and look at the pieces. Multiples are when you build up, right? You're multiplying to get there. So 15 times 1, 15 times 2, 15 times 3, 15 times 4, you're multiplying to get there. Just because we're on the topic, what are factors of 15? Ooh, so somebody said 5 and 3 immediately, and then I also heard 1 and 15, and that's it. That's it. And we don't do decimals as factors. We don't do partials really normally. We just do like whole numbers, entire values. Let's move on. So somebody got a bag full of candy.
I did.
Unless she had like 300 pieces and like nobody guessed that.
Wait, no, what was the other flavor?
We don't know. She didn't tell us. All right, this is really good. Now, I don't even want to read this out loud because I want you guys as a group to work through it. So Lyle asked his teacher for a challenge. Right? He's like, teach, you're great, but kind of boring. So she's like, fine, Lyle, have this problem. I'm going to read it anyways. The probability when you reach in this bag of getting red is 2 seconds. The probability of getting red or blue is 2 thirds. What's the probability of blue? Go for it. Read it again if you want to, but I'm not going to repeat it. Did you say 21 is not a thing? The denominator, the common denominator is 21. You're good on that.
Oh, I just wrote 1 3.
Which is bigger, 2 thirds or 2 sevenths?
2
2 thirds, right? Think about it like out of a circle or something like that. 2 out of 3 versus 2 out of 7. Yeah, 2 thirds is more. So Myra, Kanessa, and Darren have different ideas of how they're going to solve this problem. Myra says, yeah, well, first thing we need to do is make a common denominator because fractions. Kanessa's like, yeah, we want to set up a subtraction problem. And Darren's like, well, the probability that you draw either red or blue is the same as probability of red added to probability of blue, right? Because we know the or adds them. Who's right? They're all right. So, and I keep forgetting to tell this analogy or metaphor or whatever it is. There are many right ways to get to Florida. Who's been to Disney? Right? I doubt that we all drove the same way to get there. I guarantee you didn't drive the same way as me because I went and saw family on the way down there. So, all because we take a different route doesn't mean we're wrong. So one of the points of looking at a problem like this, we all think differently. So when we solve problems as a group, please make sure that you respect your classmates. And all because they're saying something different than you, that doesn't mean they're wrong. That doesn't mean you're wrong. It just means you're different. Which, I mean, trust me, I'm different. So, Darren sets this up. Kanessa sets up the subtraction, and Myra's over here making common denominators. Whatever way we take, we can figure this out. I don't know which way you took, but I like Braylon's idea of common denominators first. I heard him back there saying 21. So if I multiply by 7 on top and bottom, I'll get 14 over 21. Sorry, not equal. Minus, yeah, I got to multiply by 3 there. 6 over 21. And we get? Could there be 20 marbles in the bag? Not if the probability is 8/21. Could there be 42 marbles in the bag? Yes. Could there be 12 marbles in the bag? No. Can there be less than 21? Why? Who can tell me why? Give me a hand. There's no common factors here, not multiples, we're talking factors now. If I want to try to get less marbles in the bag, I'm going to have to do the same on top. I could divide 8 by 2 or 4, right, to get it smaller. 21 doesn't, I can't do that. I could divide 21 by like 3 or 7. No way to reduce it. There has to at least be 21 marbles in the bag. There could be more. There could be like 42 or 84. A lot of options. There has to at least be 21 because this cannot be reduced. Okay, so check for that. If you're like trying to figure out options of what could be the total, always look at, can I reduce that fraction? Solve these two spinners missing the regions. Nah. No, he said it's way too hard. Do I need to start with 1 when I go to do this subtraction? Nah, I'll give you a hint. You could just start with 1/2. I like Luis. So, we're judging the names. Are we solving this? You could start with 1 minus something, or you could just start with 1/2 minus something. The reason I'm saying we could start with 1/2 is I know all of this. If I look only at the right half, I could just do a 1/2 minus 2/5. Same thing here. I could just look at the left half and do 1/2, take away an 1/8, take away a 1/3, or other order, 1/2, take away a 1/3, take away an 1/8. Are you okay? You're like real excited or something. What is okay? That's a big question. And yeah, that's all we're gonna do today. So, hey, so keep working these. I'm going to call names to pass out homework. So please come up and get this as I call your names because it will take way too long if I try to walk around the classroom. And you'll all probably end up called up twice because you turned in multiple homeworks. Braylon, Braydin, Savannah, George, Gwendolyn, you're really funny because you typed this. Quinn, Marley, Octavio, sorry, Opie, Jesse, Teak. I had on the board what you were supposed to turn in. It said turn in this, this, this. Yes. Marin, Peyton, Mallory, Olivia, Chloe, Lizzie.
Thank you.
You're very welcome. Connor, Teak. 1-2-1 or what? Okay. Yeah, I'll get it on my planning period when I have time period. Simon, Caitlin. Did somebody actually take yours or did I call you? Did somebody take Chloe's? Check your paper, make sure it's actually got your name on it. Micah, Gwendolyn, Savannah, Jesse. What? Am I crazy? Is that crazy? Yeah, sorry, they got stuck. Chloe, that's you. Peyton, Braylon, Savannah, Micah, Braylon, Simon, Peyton, Jesse, Braydon, Gabe, Connor. I did a lot of reading. Lizzie, your name's not on the top, but it's at the bottom of your rating. Marley, Maren, OP, Quinn, Mallory, George, Olivia, Chloe, and Caitlin. Right here, you didn't have your name on top, you had it in the writing. Gwendolyn, I got one more for you. See, you guys moved, you all screwed up. Alright, we got just a couple minutes left. What is the missing probability? Well, I can't write. What is the missing probability here? A tenth is what George says. Do we agree or disagree? Agree. Agree. If I make this into half minus 2/5, I gotta make a common denominator of 10. Turns into 5/10 minus 4/10. I end up with 1/10 left. Down here, if I do a half, a third, and an eighth, weird denominator if I try to do it all at once. 1/24, because if we look at 8 and 3, common denominator would be 24. So 12/24 minus 8/24 minus 3 more 24ths. Get our answer. Questions? Keep those in your math binder for now, at least until the end of chapters. When we end a chapter, we're going to talk about what to do with that. You guys want to save some of your work for student-led conferences, so please don't start getting rid of work that we give you back. Keep it for now, and then we'll give you a place in a filing cabinet to start housing your stuff you don't need anymore. But hey, the other thing, sometimes my tests are open notes. Like open notes, open homework, open whatever you got. So you want to keep your stuff and keep it organized because sometimes it's like, yeah, use whatever you have. Because really, if we care about what you know how to do, it's not about memorizing stuff. It's about knowing how to do stuff. All right, questions. We are like done with chapter 1 essentially because we're the accelerated class. So we normally take a day for closure or some kind of review activity and then do the test, which would mean we do closure activities and review stuff tomorrow and then take the test on Friday. Which would mean there's no homework over the weekend, and then we're done and we're moving on. Are there any big oppositions to that? And if so, you have to go explain yourself. I operate my class as a democracy, so if you guys decided you didn't want to take the test like Friday, we wouldn't. We'd move it to next week or whatever. I mean, we could take it tomorrow if you're all like, forget the review activity. We'll like just move on. Okay, so because we are the accelerated class, we do need to move quickly. If y'all feel comfortable with what we've done in this chapter, we could take it. Well, okay, so there's two options. We might have to do like close your eyes and vote. We could take it tomorrow, but then Friday we'll start new content. Or we could start new content tomorrow. That homework won't get collected till next week or something like that. And then Friday would still be your test with no homework over the weekend. So I shut, and there will be an I don't care option, but shut your eyes and then I gotta get you out of here. Vote for you want the test tomorrow. Just get it over with, and then Friday is new content. All right, hands up if you want test on Friday, just to wrap up the week and have no homework going in. and all that. Hands high. I can't quite tell who's up or half up. Okay, and you just don't care. Stick your hands in the air, wave them like you just don't care. Okay, our test will be on Friday. Democracy rules. Now, even though I had you guys shut your eyes, my recording was still going. So I guess if you really want to know who voted for what. But yeah, we're out of time. Thank you guys very much. Have a wonderful day. Just in time.
Could some people just do it?
Yeah.
No, it doesn't. I mean, technically, you never really have to be in my class because you could just go watch the video. So I have had students in the past who are like, can I not come to class today and just watch the video? And, like, or if they like have an appointment or something. So I mean, technically, yeah, we could, but I'd rather you guys just do it all together. Yeah, it is good. It should say what you need to do.